All right, so welcome to part 3 of the solving equations, and this one will be on collecting all your like terms. And what I will want to do is I will always want to separate my equation into a left-hand side and a right-hand side, where on one side I put everything with my variables, and on the right-hand side everything that does not have the variable that I want to solve for. So in part 1 and 2, if you went over them, you will notice that there was absolutely no additions and no subtractions. It was all multiplication and division. And the reason for that was because on the left-hand side you had only one term, and on the right-hand side you only had one term. That is not the case anymore. So what happens when you have more than one term on one side or the right, on the left-hand side or the right-hand side? So you will notice that on the left equation, I have an addition, and on the right equation, I also have an addition. So these are two separate questions. So whenever you want to collect like terms, some of you may know that you will have to shift terms from one side to the other. So for instance, if I take on the left-hand side and I do not want, because I am solving for z here, okay, and on the right-hand side I am solving for y, that's all that I want to see. So for instance, when I want to collect like terms, I want to collect everything that has just my variable, and in this case, that's not the case because I have a -2 here, which I do not want. So I have two terms on the left. I have just this term right here, and I have this term right here. Now, this term has a z, so I want to keep it, but the -2 does not. So I will want to get rid of it and shift it over on the opposite side. So how do I do that? Well, in reality, what actually happens is to get rid of -2, okay, a lot of students, what they'll try to do, they'll say, well, I'm going to divide by -2 because they're so used to, okay, working with one term. But here, because of the plus, you cannot just say I want to divide by -2, okay? You have to actually get rid of this whole term. So what I will do is on both sides, if I said, okay, well, -2, if I add 2, and here is my -2, so notice that now, so here I'm going to rewrite the rest of it. So I have that, but because now I added this 2, I have to also add the 2 on the opposite side, okay? So that it doesn't change anything for me. So here, 2 minus 2 is obviously 0, and all I have left is 4z equals, and here, okay, so this is now 8 plus 2, which is going to be 10. And from here, you know what to do if you've watched part 1. Okay, we can divide by 4, and on both sides, and now I will get 10 over 4, okay, which is 5 over 2, or just 2.5, okay? So it depends how your instructor wants you to do that. Now, most people will not be doing this so that you can see it. Instead, what they will do is they will simply take the equation, so -2 plus 4z equals to 8. And what they will do is they will take the term and they will shift it on the other side. And when you shift, notice that the actual sign changes. Okay, so they will write 4z equals to 8 plus 2. Okay, so the sign itself has changed from negative now to positive. And that is the collection of like terms where we want to have only our variable on one side and everything else on the opposite side. Okay, so from here, it's exactly the same question, okay, and you can solve it, okay, and we just did that right there. So if I go back to this negative 2y plus 2, and I try to solve that based on what I just said, so notice I have two terms. I have 1, 2. So to get rid of a term, okay, so this I will shift over on the opposite side, and I will have negative 2y is equal to 11 minus 2. Notice the sign must change when you shift it over. So I have negative 2y equals to 9. And now I can solve by dividing both sides by negative 2. So that negative 2 cancels. Y is equal to, and this is negative 9. Okay, so this is negative 9 over 2. And again, you can change it back to decimal or whatever it is that you need. But that's how you would solve. So collecting of like terms is all about trying to shift terms from the left to the right and vice versa. Let me give you another example. Okay, so we'll do a little bit bigger example. Okay, here, so I will randomly place these all over the place. So for instance, I have 4x, okay, so plus, let's say 8 minus 2 equals to negative 3, and it can be, for instance, a decimal, doesn't matter. Let's say negative, and now I have, okay, let's say 2.5 x. So now I have x on both sides. All right, I have one term with x here, and I have another term with the x here. And now the rest of this, so what I have is I have only numbers. Okay, so these terms are all numbers. So I will bring all my x's, or all my unknown variables, to one side, and all the numbers on the opposite side. So I will shift this over here. I like to keep them on the left. And then what I will do here is I will shift these over to that side. Now remember, when you shift something over, the sign will change. So I have now, so 4x, that's that, it stays on this side. The 2.5, so the negative will change now to a positive 2.5x equals, and now all my numbers, so negative 3.2, so that stays. The 8 will get shifted, notice the sign changes, and the 2 gets shifted, and notice the sign changes. This is collection of like terms. Now I have only the variables on the left, and I have all my numbers on the right. Now we can go ahead and collect these like terms. So 4 plus 2.5 is 6.5x equals, okay, and now I have, so I have negative 3.2 minus 8 and plus 2 equals, okay, so this is negative 9.2. And now I can go ahead, so I've collected my like terms, and I can now solve. And again, how do I solve? That's part 1 of the series of videos. I will divide both sides by 6.5, and I will get x is equal to, okay, so here I have this divided by 6.5, and I have negative 1.415, and so on. Again, you can round to what you like, or whatever your teacher tells you. So collecting like terms means you have to shift all the terms on the left, okay, with the variable, and then all the terms that do not have your variable on the right. And then you can collect them, meaning add and subtract them, okay, as you like. All right, so that was another example that you have, and you can see it can be done with whole numbers, with decimals. It can even be done with fractions. Okay, so for instance, you can run into problems like this. Okay, so let's say that we have negative, okay, let's say x over 3. Okay, so plus, say 8 is equal to, and this would be negative, say 4 plus 2x all over something random. Let's put it, say, over 7. And now, so I have fractions in here, and even these can be fractions. That's okay. Okay, so even that can be fractions. And what you would be doing is you would have to find all your terms that have your variable. So this has an x, this has an x, and then all the other stuff. Okay, so this right here and this right here, and collect them. So if I do that, I have to shift this over. So this would now be negative x over 3. Notice the sign will change. So minus 2x over 7 is equal. And now on the right-hand side, so negative 4.5, and then the 8 over 11. So that shifts over. And now you have to collect them. So indeed, you're going to have to find common denominators so that you can add or subtract these. Okay, or you can use your calculator and your fraction buttons that you have. Okay, so for instance, I have negative. So this is, so let me write it, okay, just so that you know this right here. So that's negative 1 over 3. Remember, there's a 1 in front there. Okay, x minus 2 over 7 x, okay, equals negative 4 over 5 minus 8 over 11. All right. Now that we have these fractions, let's actually solve them using the calculator, so without finding common denominators on our own. So you will have to know where your fraction button is. You have done a video on solving equations with fraction, and I talk about it, so you can take a look and find that one. It's solving for an unknown, and you'll notice a fraction title. Okay, so in this case we have, so I'm going to just go ahead and input the fraction itself. So negative 1 over 3, then minus and 2 over 7. Okay, and now here I have negative 13 over 21, so negative 13 over 21, that's x, equals, now let me do the opposite side. So I have, so negative 4 over 5 minus 8 over 11. Okay, so now notice that it gives it to me as a mixed number, so I will convert it back. Okay, if you hit the fraction button again. Okay, so it will, so now I get a decimal, and now I get what I wanted, which is actually an improper fraction in this case. So we have that. Okay, and now we can go ahead and solve. So, remember that for these, okay, so in order to solve it, so I have to get rid of the left-hand side. Okay, so I'm going to multiply so that to get rid of the 21, so that cancels, and then get rid of that. And I have to do that to both sides. Now you don't have to put it in brackets. Okay, so this 21 will cancel, negative 13 will cancel, and we have x equals, and now I can go ahead and find out what that is. Now I actually have it there on the calculator, as you can see. So I'll take that answer and then multiply it by, so 21. Now because I have the calculator, it's much easier. All right, so we can do that. Okay, so we have this crazy, whoops. Okay, so we have this crazy number, 1764 over 715. Now you can turn that back into decimal. okay, if you want. So you can do the division and so on. You can leave it as a fraction. You can ask your teachers what they like. All right, so that completes this particular example. Okay, so thank you for watching. Okay, and remember, help one inspire a million. See you at the 1 million journey.